Welcome and welcome to Cambridge Chemistry channel with Sarwat Ahmed. Be sure to like the video and subscribe. It really helps the channel to grow. Today I will discuss mass spectrometry for AS level. Uh, let's start. Mass spectrometry. Mass spectrometry is analytical technique uh, which is used to identify unknown compounds. It is an analytical technique used to identify unknown compounds. Moreover, it is used to measure the it is also used to measure it is used to measure the isotopic mass, which we have done earlier. It is also used to find out abundance of isotope used to determine the it is used to determine the structure of compound and finally to find out MR of compound. To find out MR of compound. So first of all, I will discuss the small experimental detail, but this is not required uh, in the examination. But it is very important to know the basic experimental details for understanding the questions. So, method how to find out the molecules in the small sample, the molecules in the small sample are bombarded with high energy electrons, which can cause the molecule to lose an electrons to form molecular ion. Molecular ions with unpaired electron one of the electrons in the pair has been removed by the beam of electrons electrons. For example, like this is molecule, electrons are bombarded and it is converted into molecule ion and plus electron. Yeah, in other words, I can discuss like this, that for example, if this is the CH3, CH2, CH2, CH3. If electrons are bombarded in these molecules, this will be converted to remove electrons. So these electrons can be removed, and one product is the molecular ion like this. There are CH3, CH2, CH2. Let's say this is the molecular ion and this will become free radical. So in the mass spectrometry, detector only detect molecular ion, positive molecular ion. So it cannot detect radical or molecule. So it only detects the molecular ion. So this is, for example, propyl. So this is methyl is the become the free radical. So there is another possibility, by हो सकता है कि ये आपके पास आयन बन जाए और दिस विल बिकम free radical. Is that clear? So this is the splitting of molecule into ions and free radicals. So the molecular ion can further fragment to form new ions. So for example, in butane we have different possibilities like CH3, CH2, CH2, CH3. This is one possibility. CH3 will be ion and CH2, CH2, CH3 will be the free radical. So there is another possibility. So methyl will be ion, CH3, CH2, this will be ion and this can be free radical. CH2, this will be free radical. So this is how fragments molecules uh, can separate into different ions, and this is known as fragmentation. This process is known as fragmentation. Fragmentation of the molecule. So now how peaks are formed based on their masses m to charge E ratio. The fragments of ions are then separated by deflecting them into the detector. So the smaller, so this is known as uh, mass over charge ratio. So the smaller and more positively charged fragment ions will be detected first, as they deflected the most. And are more attracted to the negative pole of the magnet. So each fragment corresponds to a specific field, to a specific peak with a particular mass over charge value in the mass spectrum. The base peak is the peak corresponds to the most abundant ion. For example, this is the mass spectrometry. This is a sample in gaseous form. Entered in the mass spectrometry. Let's say over here detector is there, and this is the filament from which electrons are bombarded. So let's say this is the compound and electrons are bombarded over here, and it is going to split into positive ions molecule. So over here magnetic field, and magnetic field separate on the basis of mass over charge ratio. The smaller the sample, and this is detector. Detector only detect the positive molecular ions, and this magnetic field separates the ions on the basis of mass over charge ratio. Heavier ions are less deflected over here, while the lighter ions are deflected more. So the lighter ions, so that's why lighter ions detect first, uh, later on the heavier ions, and lighter ions form the uh, larger peak, while the heavier ion form the small peak on the spectrum. So the peak with the highest mass over charge ratio, the peak with the highest mass over charge ratio value is the molecular ion, and it is represented with M plus. Is the molecular ion peak which gives the information about the molecular mass of compound. And this molecular ion which has lost one electron when bombarded over here with the electrons. For example, this is the molecular ion and this is the electron lost. So There is another peak which is labeled with M plus 1. So the M plus 1 peak is the smaller peak, which is due to the natural abundance of the isotope carbon 13. The height of the M plus 1 peak for a particular ion depends on how many carbon atoms are present in that molecule. Depends on how many carbon atoms are present in that molecule. So for example, the height of M plus 1 for an hexane containing 6 carbon atoms. Hexane ion will be greater than the height of M plus 1 of an ethane. So there is another peak which is appeared in the mass spectrum sometimes, for that is M plus 2. M plus 2 peak M plus 2 peak if M plus 2 peak is appeared in the on the mass spectrum, so it is due to the halogen. M plus 2 peak always is peak determine the halogen atoms like chlorine or bromine is present, or chlorine or bromine. And if the and you know that chlorine and bromine has two isotopes, chlorine 37 and chlorine 35. two isotopes of chlorine are there, while and the ratio is 3:1. Abundance of these two isotopes are 1:3, or if the lines on the peak's mass spectrum like this. So this is of chlorine 35 and this is chlorine 37. So if two peaks are like this in the mass spectrums, it will be definitely chlorine. And you know that bromine also has two isotopes, that is bromine 79 and bromine 81. And if the peaks like this on the mass spectrum, अगर 1:1 ratio है, so then it will be definitely bromine atom is present in the mass spectrum. And why it is m+2? Because the mass difference between two isotopes is 2, so that's why this peak is the m+2. If m+2 is there on the mass spectrum, so molecules contain halogen atom also. So it means if both peaks have same height, on the mass spectrum, due to same abundance, then molecule contain bromine atom and if both peaks on the mass spectrum is 1:3, then molecule contain chlorine. So this is the summary of the experimental detail and different information about mass spectroscopy. In next video I will discuss the exam questions, past paper questions, inshallah. Hope you will understand this video. Please like the video and comment in the comment box. Thank you.